Hop là pas.
Good day, everyone, and I hope you are happy to be here today. It's another beautiful day to learn chemistry. I hope you are ready and fired up about today's lesson. Today is going to be one of those topics, funny enough, that has less, not really that has less practical, it actually has a lot of practicals. But uh, it has a lot of practicals, yes. But the first and foremost thing is understanding details. So if you understand details of uh, chemistry, yeah, then that's where we go to. Okay, so I got some feedback. Somebody sent stoichiometry. We did that last Saturday, I guess. We also have qualitative analysis, chemical bonding. Yeah. These are easy things that we always have to do. But today, I got a notification from one of our participants that she that we should look at oxidation and reduction. In fact, haven't done electrolysis, haven't done chemical equilibrium, haven't done periodic table. It's very important that we do oxidation and reduction. Okay. Ha- for me, in those days in secondary school, did I really do oxidation and reduction? Yeah, I did it, but I don't know what it was all about. So when I was in university, uh, I did redox reaction, but I don't know if I still understood it. Maybe because I didn't have good background. So one of the things that we need to always take a pay
Tell me
careful
where is
attention is
showing.
uh, understanding it. Yeah. So whatever we are doing in university is still the same thing what we are doing in secondary schools. I can't lie. So what we do here, we extend it to more
Clean your hand with
content.
that clothes.
So if you are doing three examples, if you are doing simple, if you are doing, our oxidation and reduction is just first 20 elements and some few other elements. But when you go to university, the oxidation and reduction is all the elements. It has some element that have 6 oxidation states, 5 oxidation states. You have to, don't have any choice. You have to do all of them. All right. Okay, I think all the sets for today's lesson. Yeah, so let's rock and roll. So I haven't cleared all the available background noise and challenges that we could face. Let's go straight to the business of today. Okay, I remember my humble self, your host for chemistry lesson. So towards the end of towards mid July, so we can start looking at other subjects. But I just hope that we'll have put all the things together. One of the reasons why I'm struggling or we're having struggles with other subjects is um, teachers actually. So it's not easy getting teachers that will teach for free. So that's the truth. So, but we hope that if we're able to get teachers that will teach for free, fine. If we are not, we have to engage teachers, and that means it will not be free again. So that's just the point. So I don't want to do a lesson that students will not enjoy more. So if we want getting the right teacher is very very important. Yeah, and also getting teachers to do it at a very and it's free. So so you guys don't have to pay. So but till then, we keep exploring. I know I have people have said what about physics, what about further math, what about biology. It's not easy getting teachers out there for free. So that's the, but if we're able to get, then that'll be fine. If we are not able to get, we'll try and see if you guys have to pay. But I don't like that option. But if that's the option, then we only allow people that are able to afford for physics and maybe math or further math. So depending on your needs. Okay, so having said that, let's rock and roll. So let's go. So today I look at oxidation and reduction reaction. Um, so oxidation, you can see the word oxidation and look at this word reduction. So by the time you try and combine the two words together, they actually form a very interesting chemistry word. They call it redox. Alright, so it's oxidation and reduction reaction are called redox reaction. So today the PowerPoint has been done in a way that the simplest of English terminology. So let's see the original those original definitions of oxygen of oxidation. So here you said when substances combined with oxygen, you say that is what oxidation. So you can look at examples, all combustion, all substances burning. So remember in organic chemistry where we talk about chemical properties of hydrocarbons, we always say combustion. So combustion is a very simple example of what oxidation. So you can see here methane combining with oxygen to give us carbon dioxide and water. So this is an oxidation reaction. All right, so I have another one, rusting. Okay, rusting is also another phenomenon. We have iron combining with oxygen, so forming iron rust. So that's an oxidation reaction. So let me just stress a little more here. When a substance combines with oxygen, we say it's oxidation reaction. So here, methane did not have oxygen before, but here the combination with oxygen has led to a chemical change, formation of new products. Now our interest here is oxygen becomes what is being added. So that becomes our oxidizing agent. While methane that does not have oxygen originally becomes our reducing agent. So methane removes oxygen. So you can see it removes oxygen either from like in this reaction now. So methane is one that is removing oxygen. So that's the reducing agent. Okay, so while oxygen is one that is supplying the oxygen itself as oxidation. So we have some other reactions that you can see here. Let's say, for example, uh, zinc oxide combining with carbon will give us let me get used to it. Will give us zinc plus CO2. So if you look at this reaction, you discover here that this is another example of uh, comp- oxidation reaction. Here, the zinc oxide was having oxygen here, but carbon has taken the oxygen. So zinc oxide is one that is donating the oxygen. So zinc oxide is described as the oxidizing agent. While carbon, that is one that's receiving the oxygen, is described as the reducing agent. So I hope that's very clear. So now one of the things I always tell students that oxidizing agent and reducing agent are usually reactants. They are usually reactants. So in Nigerian curriculum, they can also define oxidation in terms of oxygen transfer. So oxidation is the addition of oxygen. So the other process is removal of oxygen, and that is all called reduction. Okay, so the substance that donates the oxygen is called the oxidizing agent. Um, the substance that donates the oxygen is called the what? Oxidizing agent. While the one that receives the oxygen is called the reducing agent. So I decided to use Ra and OA to describe my oxidizing agent and my reducing agent. Hope I'm not too fast today. I want it to be very clear so you can understand it. So you can also define this oxidation and reduction in terms of oxygen transfer, in terms of hydrogen rather. Okay, look at this one. Same way, reduction. I think I've already described this. It's a reaction where a substance gave up oxygen, like here now. So where our focus should be on ion 3, Fe2O3. Here now, this ion 3 has given up its oxygen. So you can see here, that means um, ion 3 has undergone what? Reduction. So look at it here. It has given away its oxygen. While this carbon has undergone reduction. So ion 3 is one that is donating the oxygen, so oxidizing agent, while ordinary carbon is one that is taking the oxygen called reducing agent. I hope that's very clear. No big deal. Okay, we are making sense, right? So I also have another definition that has to do with hydrogen too. Uh, okay, so oxidation involving the removal of hydrogen, the same way we have this kind of oxygen, while reduction involving the addition of hydrogen. So the same thing. So but here I want us to focus our attention on modern definition here. That is we are dealing with here with electrons. So why this is why I have to say this is modern definition, because you don't necessarily have to say oxygen must be involved. We have reactions where oxygen is not even present at all. So do we describe that as oxidation, or do we say that cannot be described as an oxidation reaction? Okay, so here I think oxidation and reduction involve transfer of electrons. Okay, so during a chemical reaction. So here oxidation involves the loss of one or more electrons. Okay, so that's oxidation. While reduction involves the gain of one or more electrons. You cannot just say you cannot lose electron without somebody gaining electrons. Just like in real life, you cannot say you are a giver when there is no receiver. Is it possible? Imagine only you are the only one in the whole community, and you just describe yourself as the most generous person. Indeed, obviously you are not the most generous person, because you cannot just give to empty land. So people has to receive whatever you are giving. Alright, so you can see here, oxidation involves loss of electrons. So substance must lose, while the other substance must gain. Okay. Alright, so here let's look at what happened here. Both reaction must always come occur at the same time. So I've gotten a wire question where the wire says um explained why oxidation and reduction processes are complementary. Oxidation and reduction processes are complementary. You know what that means? That means they go hand in hand. You know, in demand, we have different types of demand: derived, competitive, composite, and complementary demand. I still remember my economics very well. So, complementary, I don't have to start defining demand, but here in chemistry, oxidation and reduction are complementary processes. That means for one to lose, there must be somebody receiving, right? So the person receiving is usually called the oxidizing agent. The person receiving. So the one that is giving is usually called the reducing agent. Take note of that very carefully. Oxidizing agent is usually the electron acceptor, while the reducing agent is usually the what? Electron donor. Okay, so generally we know that metals are very good with losing electrons because they have um, an extra electron and an extra shell. So they usually have to lose electrons. So we say metals are generally good reducing agents. So we say also non-metals also, they have close to 8 electrons. So they, like chlorine, oxygen, nitrogen, they have 5, 6, 7. So they should be good with receiving electrons. So we describe non-metals as electron acceptors. So non-metals are usually described as electron acceptors or oxidizing agents, while metals are electron donors or known as reducing agents. Okay, so let's see how we can talk about their electron change. Now, because we are dealing with electrons, so we have to always know here that when an element, mind my word now, I'm talking about an element. When an element is not combined, that means it's on its own. It's not combined. So that means sodium here is on its own. Chlorine here is on its own. It is not combined with any other element. So when it's in its free state like this, so we describe the oxidation state as zero. And when I was preparing these notes, I didn't want to start giving you rules for assigning oxidation state because I'm dealing with students who are smart. Yes, let me use that word, smart students. So I can't be taking you back to SS1. It will just be wasting our time. So somebody will ask me, what about this chlorine? But there are two. When they are like this, what kind of bonding is this? Covalent bonding. Is there any electronic charge? No. So since there is no electronic charge, so automatically we assume that the electrons are balanced because they have shared electron. So sodium is on its own here, is not attracted to anybody. Since it's on its own, it does not have any electrical charge. Yeah. So since sodium does not have any electrical charge, we assume that the oxidation state is zero. Okay, very, very important for us. So, but here, if you look at this compound there, sodium chloride, that's a product they've combined in form of NaCl. So it's covered here that when they combine, sodium has lost an electron, so it's positively charged, while chlorine has gained an electron. So take note, this is the electron that has been gained, not these two. These two means there are two chlorine. These two here means there are two chlorine, but here, this one is electron charge. Okay, so we say that the oxidation state of chlorine has gone from 0 to -1. Can you imagine? While oxidation state of sodium has gone from 0 to +1. So I want you to write this one down now. Oxidation is and can be defined as an increase in oxidation number. Oxidation can be defined as increase in oxidation number. Okay, while the reduction is decrease in oxidation number. So the question is, what is oxidation number? Oxidation number, I think I have that definition in the other side. The electrical charge an element appears to have. The electrical charge an element appears to have when it is free and also when it is in combined state. So when it is free and when it's in combined state, that's what called oxidation number. Okay, sir, I'm not hearing you. Can you hear me now? Thank you for notifying that. Can you guys hear me clearly? I'm not shouting today. Maybe because I'm using earpiece. Can you hear me
Yes.
clearly? So I need feedback.
Yes.
I can't hear. It's probably harness, so I can hear you. Okay, thank you. All right. So as is, just try and be patient. Your network should be able to be back and stable. All right. So okay. So you can always use this to remember oxidation, loss of electron. Okay. While reduction, gain of electron. So Leo the lion says, "Grrr." Just so these are different things that you can use to remember. Okay. Right. Okay, so now there's what we call conservation of matter. You remember that law of conservation of matter? In essence, so say matter can neither be created nor destroyed. Yeah. Here also we have conservation of charge in chemistry also. So when there's conservation of charge, that means electrons will either electrons are usually conserved. What that means is that the total number of electrons lost will always be equal to total number of electron gain. So that's conservation. So you don't say, I lost an electron. Another person say, I gained 2 electrons. Why is there a difference? Okay, so that's say conservation. So here, take note of this: oxidizing agents and reducing agents. We almost get to the business side of this topic. So during oxidation, oxidizing agents are substances that are reduced. What that means that they usually gain electron. Very interesting. Let me take you back a little. Look at this chlorine here now. Chlorine here, the oxidation state is 0, and it has changed to -1. The oxidation state has been reduced. So whenever you are trying to describe oxidation and reduction, just look at the species involved in the reaction. When the oxidation number is reduced, so that species is the oxidizing agent. When the oxidation number is increased, that species is the reducing agent. Okay, so the reducing agent experiences an increase in oxidation number. It experiences an increase in oxidation number, like that sodium you have here. Sodium goes from 0 to +1, so there's an increase there. So we describe that as uh, oxidation. Okay, very very important. All right. Okay, so that's by the way. Okay, very good. Then we also have, both of them are usually opposites. You can even see this reaction that we have here. Um, we have magnesium reacting with oxygen to form magnesium oxide. So you can always know that. The another quick thing that I don't need to be teaching you how you can determine the oxidation state. But one easy rule instead of cramming is, you can't cram everything, but you can learn a lot of things. Magnesium is usually 12, the atomic number is 12, oxygen is usually 8. So do your electron distribution. When you do your electron distribution, that is, this one becomes 2, 8, 2. Alright, this one is 2, 6. So automatically, oxygen will likely gain for it to be stable. How many should the oxygen gain? 2, right? So if it's gaining, electrons are usually negative charge, so it becomes -2. This sodium, this magnesium has to lose this 2 so as to attain its octet state. So how many should it lose? 2. So that's why it's usually +2. So that means the protons are more by 2, while the electrons here for the oxygen are more by 2. Okay, I hope that is clear. So any element at all, if you know the atomic number, you can easily identify their oxidation state or oxidation state obviously. Let's say for like nitrogen here now. Nitrogen is number 7. That's atomic number. So if I do that, that's 2 and 5. So how many is nitrogen expected to have? It's going to gain 3 more. Alright. So nitrogen is going to gain 3 more. So that means, what does that imply? If it's gaining, that means it's going to gain 3 negative charge. So the oxidation state of normal nitrogen is usually -3. Okay, so you can do that for every element. We can have a question here. Sir, please, what is a redox reaction? Okay, so a redox reaction is a reaction that involves oxidation and reduction. A reaction that involves oxidation and reduction, in which one element is losing electron while the other element is gaining electron. Take note, as a redox reaction is a reaction involving oxidation and reduction, in which one of the species gains electron while the other species loses electron. Okay, so I say in which one of the species is oxidized or the other species is reduced. So I think this is what the slide I was talking about earlier. Thank you, Aziz, for that question. Please ensure that you always use the chat section to contribute and ask questions. If you want to say anything, no need to keep mute. Just raise your hand, then you can unmute yourself when I permit you to. Alright, so that is quite important for us to take note of. Alright, so let's push forward. I think we are making sense. So from this slide, these are some rules for determining the oxidation state of any reactant in a given reaction. Okay, so should be able to get through it. All elements when they are combined, I think I've said this, they usually have the oxidation state of zero. Okay, so that's here. Okay, so if it is like this, that means the oxidation state of this species is plus 2. If it is like this, that means the oxidation state of this species is plus 1. So obviously, what should be minus? This one will be, so this one should be minus 2, right? Okay, so I am confused. Um, I, I want you to explain to me what which side are you confused? If an element is losing an electron, does it mean the oxidation number is increased? Absolutely beautiful. That's very correct. Now let me take you back to basic chemistry. Now let's say for example atomic number of an element. Let's let's take lithium. Lithium is number three, element number three. So that means the atomic number is 3. So it has 3 protons and it has 3 electrons. This time should take this time. I can't be. Alright, so if it is losing an electron, so remember protons are positive while electrons are negative. So if it loses an electron, let's say it loses electron now. So what happens there? The protons dominate. If it loses one electron, the proton dominates. So that's why we now write Li plus. Like let's say for example, oxygen is number 8. Okay, so it has 8 protons and 8 electrons. And remember, electrons are negatively charged. If it gains extra electron, what will happen here? It will now become 9 electrons. So that means the electrons will dominate and it become what? O minus. Okay, so I'm confused. Let me see. You said oxidation is the loss of electron. Okay, yes. You also said oxidizing agent gain electrons. That's very correct. Okay, now thank God. I appreciate the fact that you said oxidation is loss of electron. Now, I want you to. There's this notion that students usually get when their teacher is defining this oxidation and reduction. Please tell them to join back after this end because we have some new people that here might not know. Okay, all right. Thank you very much. All right, so remember this meeting usually we have 2 sections, the first section and the second section. First section, this lesson is supposed to be for 1 hour. So we spent about, because I logged in early like before, some few minutes before 12, so I can start receiving people. Um, so in the next 8 minutes, so we'll log out and we'll log in again. Okay, so please don't assume that we have ended the lesson until I tell you goodbye and see you next time. Okay. All right. So now let me explain to that my friend that says I'm confused. Now, whenever we say oxidation, please disengage whatever you have heard me say or whatever your teacher have said. The oxidation is a process. Is a process. The way you say when you are defining something in chemistry or any other, so you say this is a process whereby blah 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 blah. So oxidation is a process. So that process that involves loss of an electron is called oxidation. The process that involves loss of an electron is called oxidation, while the process that involves the gain of electron is called reduction. Now, for us to be able to have that oxidation, what usually happens for every element, whenever an element gains electron, it's either, yeah, when it gains an electron, so the number of electrons will increase, so it becomes more negatively charged. So when it loses an electron, so that means the number of electrons will decrease, so it becomes more positively charged because in every neutral atom, the electrons and the protons are usually equal, so they cancel out. So when the electrons are more, that means the electrons are more, so it becomes negatively charged. When the electrons are less, whenever there is a loss of electron, so the protons are now more, so it becomes positively charged. Okay, so that's very, very important. Now, whenever there is for any given reaction, you cannot just say electron loss or electron gain. there are substances that are responsible for that loss of electron, and there are also substances that are responsible for that gain of electron. So substances that are responsible for the loss of electron, that means without them, there won't be any loss of electron. So why? Because they are willing and ready to collect the electron. So those substances are we call it oxidizing agents. So those oxidizing agents are those species that are responsible for the loss of electrons. So that means they are ready to gain electrons. So whenever they are there, whenever there is an oxidizing agent, electrons will always be lost because they are there to gain the electron. So oxidizing agents bring about oxidation. So that's why we say oxidation is the loss of electron. So for us to have oxidation, there must be an oxidizing agent. If you turn it around, if you turn it upside down and talk about reduction, we also have substances that are responsible for the gain of electron. Those substances that are responsible for the gain of electron, we call them reducing agents because they always lose electrons. So whenever they lose electron, this other species will automatically gain electrons. So we now say here that oxidizing agents are electron acceptors or they gain electrons, while reducing agents lose electron. We call them electron donors. Okay, so thank you very much. I hope I've clarified the misconception. All right, so these are different ways you can calculate your oxidation state. Maybe just for the, I will have to put it because these are also available in the WAEC past question also. So here you want to calculate the oxidation state. Now it's always important that you calculate the oxidation state because without knowing the oxidation state, you will not be able to predict if that particular species is undergoing oxidation or is it undergoing reduction. Let's take for example chromium here in the first example here. Chromium, the whole compound here, I told you here, the whole compound here, they are the one that own this minus two. They are the ones that own this minus two because it's a it's a radical here. Both of them are combined, have already combined. So, but we have two chromium and we have four oxygen. So we need to find out the oxidation state of this chromium because most of the time in a given reaction, the oxidation state usually change from one thing to the other in a given reaction. Okay, so it's very important that we added. So we'll see those changes in the next slides to come. All right, so chromium here. So just the whole compound is carrying this minus two. This minus two was contributed by both. So we need to know that here, from here, oxygen usually contribute minus two. Oxygen usually contributes two negative charges. So that's why the oxidation state of oxygen is usually minus two. So if you count how many oxygen that we're having here, four. So four times minus two will give us minus eight. Okay, so that's what I have here. And two times, since we have two chromium, we have two times Cr, that's two Cr. So if you carry this two to this side, this eight to this side, it becomes positive. So minus 2 plus 8 will give you 6. So dividing through by 2 will give you plus 3. Now, in the exam, if you after calculating, you know your answer is 3. Very good. So if you write it CR is equal to 3 without putting this sign, you've not done anything, you've only lost the whole mark. So it's always very important that you put CR is equal to plus 3. You put the positive sign to indicate that it's positively charged. Look at this compound here now. Chromium in the same way. The second example here shows that chromium does not have any oxidation. The whole compound here, look at this, K2Cr2O7 is not electrically charged. So that means the oxidation state is 0. But in the first state, in the first question, the whole compound was carrying a minus 2 sign. So that's why it is having minus 2 here. Look at this other one, NH4. NH4 you put for here. That means the whole of this compound here is carrying a plus one sign. So the plus does not belong to only hydrogen, but it belongs to both of them. Alright, so it's very, very important that you take note of that. So you can see here that chromium here is now, by the time we finish solving it, potassium usually have plus one. Chromium, we don't know that of chromium. Oxygen here, we don't know, oxygen is usually minus two. And at the end of the day, we get that chromium here is plus six. Please take note that it has to be plus six. Okay, I'll send the note to you all at the end of this lesson on the WhatsApp group. Okay, very, very important that you take note of that. Now, we are asked to calculate this just for us to practice. So this compound is not carrying any charge. So let me just use text, I'll be faster. So I will have K. plus K plus Cl, okay, plus how many oxygen do we have? Three. So three O. Let me use this bracket to differentiate it. The cold compound is kind of zero charge. So potassium is group one, so it has plus one. So it's plus one. We don't know. You say we should calculate Cl there. Okay. So plus Cl. Okay. Plus um, plus three three of oxygen multiplying by the normal minus two that oxygen will always contribute. Everything will give us zero. So at the end of the day here, um, Cl is equal to plus 5. Alright, so if you do your mathematical arithmetic, Cl should be plus 5 then. Alright, so thank you, Aziz. God bless you. Alright, so you can see here, okay, we have a minute, so please kindly sign out and sign in again. Esther, thank you for doing the second one. God bless you. All right. So please sign out now so that